Okay, great. So we're live and I can see that there are already participants who are coming in. That's great. Well, in that case, I will just start talking. Why not? So hello, everyone, and everyone who will be coming soon, I imagine. Welcome to 3D Natives webinar, How the Concept Cars of Tomorrow Are Made with SLS and SLA 3D Printing. My name is Madeline Pryor, and I will be the moderator today. I am also joined by our two panelists, Shay Muradi and Anthony Barnicott, both from Vital. Good afternoon to you both.
Hello. Oh.
I will introduce myself and the panelists in a little bit, but before we get started and while people are still trickling in, I just wanted to take the opportunity to just send you a little poll about you and your expectations for the webinar. You should be able to see it on your screen and you can start to vote. I will just give you the opportunity to start. And I'm going to keep talking, actually. Yeah, okay, so if you could just take this opportunity to just take a look at this and vote. Some of the questions are multiple choice, some of them are single choice, as you'd like. I will just give you a few moments to do that. And well, also to let you know, the webinar today is being recorded. It will be available later on YouTube. Through 3D Native's YouTube channel. If you would like to be notified when it's online, you can subscribe. We have a lot of other exciting 3D printing content, including previous webinars. It will also be available through Formlabs, so that's something you can check out. Also, just in case, we will, as you know, have a Q&A at the end of the session. Please do ask your questions for the Q&A in the bar that's at the top bottom of the screen that says Q&A. This just ensures that any questions you ask do not get lost. The chat can get quite busy. If they're in the Q&A section, I will see them. You should also be able to vote for questions for attendees that you see that you like, and that way I can pick some of the more popular questions. But please do remember to send it in the Q&A section and not the chat, because it is highly likely I will not see it in the chat. I'm just going to give a few more moments for the people coming in. We're still trickling in here to vote. And I will close it in just another moment. Again, some of the questions are multiple choice. Some of them you can have multiple answers. Some of them is just one. It's just really to get some information about you and the webinar before we start, so that we understand what you're interested in, especially. And I can see there's a couple more people, so I'm just letting that go. And okay, well, I think I will end the poll in that case. So you can see, and I'm just going to share the results. So as you can see, for some of the questions, I see that many of you already use in-house 3D printing, which is good, and you're already using actually FDM. Closely followed by SLA, and you're looking into getting a deep understanding of 3DP. That's the vast majority of you, which is good in automotive, because that is what we'll be talking about. And now, if we can just go to the panel, to the agenda. So as you'll see here, this is the agenda for the next hour or so. In this introduction, I will, of course, introduce you to the panelists, as well as the topic overall of AM in the automotive sector. But after that, Vital will take over, introducing themselves, as well as talking about the AM applications for concept cars. And we will end with the Q&A section. And so now to introduce you to the panelists. First, for me, my name is Madeline Pryor. So my name is Madeline Pryor. I am the English content specialist for 3D Natives, which is the largest international online media platform on 3D printing, and is available in 5 languages, English, of course, but also French, German, Spanish, and Italian. I will be the moderator of this panel, as well as the Q&A. A reminder again to all of you, any questions you might want to ask, please do ask in the Q&A section. You should be able to upvote, and it makes it much more likely that I will see your question. So let's turn now to Anthony Barnicott, who is an additive manufacturing lead and design engineer at Vital Auto. Anthony has spent 10 years working in the niche vehicle sector before moving to Vital as an engineering support body for the design studio. He quickly began to see the freedom of design that came with additive manufacturing, a fact that I'm sure many of us something many of us have experienced, and so has spent the last 3 years growing Vital's foothold in this sector. He now oversees the operation of 5 Fuse 1s, 3 3Ls, and over 10 large format FDM printers, all working together to create some outstanding results, some of which you'll be able to see later on. Next, we have Shay Moradi, who is the VP of Innovation and Experiential Technology at Vital Auto. Shay and the team at Vital are analog aficionados in an increasingly digital landscape. They are leading the way for their clients in bringing insights, imagination, and making skills to projects from their base in Coventry, UK. Shay initiates design investigations and research into areas of growth in creative technology and experiential design. And just for those who might not know, because we'll be talking about them a little bit, since that is the technology that we'll be discussing today, Formlabs actually is not a panelist, but they will be discussed. And they, in case you don't know them for some reason, they're headquartered in Somerville, Massachusetts, with offices all over the world. And they're known to be manufacturers of professional 3D printers with SLA and SLS options. And let's get into the automotive sector in that case. So
thank you first of all for the introduction as well. I really appreciate that. That made us sound like we know exactly what we're doing, which is great. Look forward to sharing what we know.
Well, I hope you do. I guess we'll find out. Well, in that case, just generally looking at the additive manufacturing in the automotive sector, this is actually one of the sectors that has been increasingly integrating additive manufacturing, and not just for applications like tooling or prototyping, as you might think, but also in end-use parts, which you'll see in a little bit. And in this graph, actually, which I found from reports and data, you can get a small screenshot already of the market. It's expected to grow rapidly at a CAGR of 7.5%. And though about 20% of the market is, of course, dedicated to metal, that's only about a quarter. And it shows the continued importance of SLA and SLS and polymers, especially in the sector, despite what many might think. A lot of the new technologies in the sector are being driven by government financial support as well as large-scale applications. But what is perhaps particularly interesting for this particular webinar is at the bottom right. Here it notes that the expected applications for AM are in the automotive sector. And while, of course, there's a large segment for prototyping and tooling, there are actually, it's clear that R&D and innovation and manufacturing complex part are both becoming increasingly important. And moving on to another important question, and the slide is, why exactly is additive manufacturing being used in this sector? Well, I believe most, if not all of us, have heard of the benefits of additive manufacturing. It, of course, allows for the production of lighter, cheaper, more complex parts, which are probably benefits for the automotive sector especially. And in this picture here, you can actually see some of the current applications as well as future applications for AM in the sector. Some of the leading ones are cooling vents, bumpers, windbreakers, pumps and valves, with some of the future applications being hubcaps, tires, embedded components, and more. Though actually, if you take a look to the picture on the right, you'll notice that this is actually already a reality for some of these future applications. This is a hubcap that was printed by BMW, an optimized lighter hubcap, showing that AM is rapidly accelerating in the sector. And given the innovations in only a couple of years, I think we can all expect it to go even further, as I'm sure both Anthony and Shay will show us in a little bit.
We're absolutely itching to get sort of sharing. Why don't we see hubcaps like that? I haven't seen any like that. Have you? No.
You'll have to ask BMW, or you could do it yourselves. Why not?
Yeah, precisely that.
But, well, that's actually it for me, and I'll leave you in the capable hands of Shay and Anthony. Well, I hope. Once again, welcome, and let's get started.
That was a really great intro. You know, obviously sets the bar for what we're going to share as well. I think in this particular case, I'm going to leave on this slide for just a second to say that this obviously represents quite a comprehensive spread of different things that may be happening or is currently happening. Maybe it's in the near future, maybe it's in the far future. But one of the things that it kind of really misses out is that you could be doing the same things that you used to do before, but you're doing it far more sort of cost efficiently, and you're doing it very competently, but to
more time efficiently.
Yeah,
as well.
to very, very compressed timelines. And I think for us, because we're in the sort of game of showing what something may look like, the closer and the quicker you can get to that point, the better, really. So that brings me on to who we are and what it is that we actually do, and how we've become to be who we are effectively in this sort of space. With thanks again to Solid Print as well, who originally kind of introduced us to
they support us for all our 3D printing technologies here at Vital, via obviously Formlabs.
So one way to describe what we do is that we're actually an industrial design studio. So a lot of the work that we do is about new product development at the point where you're assisting with the discovery phase, where you're analyzing the needs and requirements for why something should exist in the first place. It's not just that we get given a specification and say, build this. There's plenty of people who can do that. And, there was a time when that's all we did. However, I think our role has morphed into sort of occupying more of that sort of product development landscape. The more high fidelity things you make, the more people ask and draw upon your expertise to show them alternative visions of that as well. To the point that we now have a clean room. We are manufacturing end components for a car that is in the luxury sector, and it's still classed as low volume when it comes to producing that specific part, and that we'll get into that in just a second as well. Everyone comments on our offices looking cool. It was just the necessity of the space that we were in, and it was one of the cheapest ways in which we could set up some offices at the time and not sort of make internal sort of structural changes. So it's inadvertently cool, but we'll claim that it's cool for a reason, and it's all very, very beautifully designed, which it is. But I like coming here and working. It's got nice sort of tones, and it's got an industrial feel to it. Bring us on to how and why we use additive manufacturing. I think Anta's sort of best place to give you specific examples, because the more I sort of dwell on it, the more abstract it seems. So Ant will sort of give you the lowdown on how and why.
Yeah, sure. So as Shay said, one of our jobs is to explore the unknown. People don't come to us with always a set idea or design. Sometimes it's just a vague thought in their head. So what the 3D printing allows us to do is turn those ideas into tangible items that we can actually physically test. So on screen, you can see there is a very boring looking door handle mechanism. Now, typically that would be an injection molded process. Obviously, it's not a route we want to go down when you're testing out a component. So that was actually printed on one of the Fuse ones. And I think that was done in about 15 hours overnight. So
what's the equivalent process if we were to kind of go down the injection?
So the reason we had that on there as an example is because there's not really any other process where we'd be able to produce that part
so quickly.
Just physically. CNC machining would not be able to achieve that geometry. There's too many internal cavities, undercuts. You'd get close, but you won't get the physical part. In terms of the time frame, again, nothing out there really.
So from essentially from sketch to the design concept to the engineering, you're talking a significant amount of sort of time compression, and without 3D printing, it's just simply wouldn't be possible. So the same things that might apply in other areas become even more salient in the area of automotive design, where if you think about the future landscape that we sort of live in now, effectively you've got electrification and several new sort of topologies and cars that are coming into play from every manufacturer. So more than ever, they need multiple properties to evaluate and test those things. We're off to one of our clients on Thursday to evaluate something that we've made for them, but we're using an ergonomic assessment tool that we've created that uses machine learning to look at this sort of model. Without all that sort of model in place, what have you actually got to base it on?
They'd
have to build the car first and then sort of go. So this is
why as you see in the images on the screen, we don't have one SLS machine. We've actually got 5 on site, because we tend to find that we don't produce one design and then try it and then move on to the next one. So it allows us to produce multiples all in one go.
When I was sort of describing to my grandma what it is we do, and I described sort of 3D printers, and the common sort of misconception is that we print an entire car. Couldn't obviously be further from the truth. You can do. We attempted that in the early days, to sort of build our own sort of large format 3D printer. We had help with it as well, and it became a nice little marketing tool for us. But ultimately, you learn that in order to make something, and you'll see an example of this a little bit further down the line, in order to make something, you break it down in multiple parts. Anyone who's familiar with 3D printing would probably come up with those sort of same challenges. Those exist on scale as well. So just to sum up, without going overboard too much, we focus on high fidelity making. And sometimes that involves obviously understanding the brief and doing all that kind of stuff. And it's become part of our identity. But really, we're taking something from a concept, a very nascent sketch, a kind of like an idea through to the final sort of stage. And it just looks completely indistinguishable from, well, it is reality, really. And we've been doing this for ourselves and for these sort of automotive clients. And that is the landscape of the new and old, really. It does represent a significant sort of footprint in automotive when you consider some of these sort of companies are actually comprised of multiple companies. And these are the only ones that we can actually sort of really put the logos on there and mention. There's plenty more on there too. What does it actually look like, though? How high fidelity are these things, and what varying degrees of resolution does the additive manufacturing sort of come into it, and how sustainable is it?
Yeah, I mean, obviously looking at screen, you'd probably be hard to pick out the printed parts from the non-3D printed parts. But in terms of what we do here, we can produce anything from optically clear lenses to, as I showed you before, structural, functional parts. In terms of our larger scale models, we tend to print all of our models in PLA. It's a sustainable source material, and of course it's a recyclable material as well. So once these models are validated, tested, and they've carried out the requirements they needed, they can be suitably recycled.
Absolutely. And where possible, if we think about the sustainability journey as well, some of these sort of properties allow us to evaluate things more sustainably as well. You don't necessarily need to build in all of that resolution from the start. You could, effectively use VR and AR. Very frequently, we're using sort of AR in our reviews as well to effectively evaluate some of the features that would be either too time consuming or too costly to create and then discard effectively because you've just evaluated it to be incorrectly proportioned or whatever.
I mean, that's becoming quite valuable to us. Obviously, anyone with a 3D printer at home knows that the faster you print something, the more you compromise the resolution. But when we're using, as Shay described, AI and virtual reality, that loss of resolution is
it's imperceptible because
exactly.
you've got a shield in front of you.
So we're able to speed up the timeframes even faster without a loss of quality.
Yeah, if you're interested in what those sort of cars are, the top right hand side is the Neo EP9, and the bottom is really the Naran, Naran, and you can look it up later. They've had significant press coverage each. Through to creative form, a lot of the skills that we actually have, and obviously we've got friends who are exceptionally creative in this space. One of our friends, Rob Melville, he's the chief designer at McLaren. He posted something that I was particularly fond of in one of the darkest years in 2020, and it's push the button. We won't use the word the trademark here, but effectively this character was something that we took from that early sketch through to an art object with 6 figures attached. And we did that again using similar techniques that we do. That model was not sort of done in one piece. It can be done in one piece, but we definitely chopped it up in multiple sort of sections before it got sort of.
This was probably quite a fun project for me to print. Typically, as we've been talking about automotive, that's the majority of my background and what I was working with. So when Shay approached me and said, "Can we 3D print a giant Mickey?" it was quite an exciting thing to be part of.
This is the sort of finished quality of it as well. When you look at it, it's almost like a vinyl figurine, but on a much larger scale. So that's it really in a nutshell in terms of how that journey sort of takes place. We try to understand something, we imagine what the outcome is, and we make it. And I think because these things are so close, from the imagination to the making part, you are bridging the gap ever closer. You're bringing these sort of three areas really in close proximity to each other, and trying to do it under one roof as well, so you don't really get any mixed messages. And it's always fun working on your own projects as well. So just to go more specific on our additive manufacturing technology as well.
So I know it was mentioned at the start by Madeline, but we started off with just 2 of the smallest Ultimakers you can get. From there, then we went up to 10 large format FDMs, which I'm about to increase that by another 30% in the coming weeks. We've got 3 large format SLA machines, and we've also got 5 of the fused ones. The fused ones are our latest addition to our collection of printing technology, but they've already surpassed, I think I'm over 10,000 hours now across our 5 machines.
So for people who aren't familiar with the differences between the sort of 2 technologies or processes, would you be able to give them a kind of a brief overview?
So typically where we'd use them, obviously their usages can be unlimited, but how we use them here at Vital is our SLSs tend to look after all our structural and functional geometry. We use our SLA machines for all our finished parts, so parts that you see. There's a example coming up actually.
Yeah, anything that's on the surface.
If it's touch points, and
so this tactile.
And then we use our FDMs for our PLA printing, which produces our sort of large scale sustainable substructures. Really.
And there is a very vast and extensive library that Formlabs have that is obviously supported, and it's not. I think they've done all the experimentation and product development effectively, so that we can. That's one of the biggest things for us, is that when you're working in a sort of a high jeopardy, very critical or mission critical setting, you really don't want to mess about and figure out what the different sort of tolerances are, and will this sort of material match this other material that we've got, and what would the tensile strength of it be, and this is where it's great to do experimentation in your own time, but I guess with Formlabs and that sort of professional setting, they've done all of that, and they've taken the uncertainty out. So if you really want that certainty of outcome, you've got access to one of the best sort of material libraries.
Absolutely. Out there. Not only that, with our SLA machines, it enables you to do material changes in under 30 seconds. So if you do want to switch between materials for various projects, there's no real time constraints there or downtime. We try and utilize as many as,
and when there is, it's you're talking a matter of hours and a bit of work. It's not for the SLS stuff. Yeah. Great.
So that obviously moves on to the SLS material, as we were saying. So we predominantly use nylon 12 here, simply because it's a solid, good all-round material. Nylon 11 is slightly for more production parts, which we are sort of slowly moving into now. But again, material change for a fused one is, it's not minutes, but it's not days like you typically find in a much larger format SLS. You could probably do a full material change in under an hour. So that's obviously an example of one of our print farms here at Vital. You can see obviously our SLA machines.
I like that. We're calling it print farms now.
That's
That's got a matrixy vibe to it. It's like cultivations, kind of. Yeah, I like that. Good. Okay, so some applications.
As I was obviously briefly touched on earlier, this is a great example of an SLA application. So what you see here is a proprietary item, an air vent from an existing vehicle on the road. We'd have a client approach us and say, I want to use this product in my car, in my vehicle, but I don't want to obviously house it in the same way that the OEM does. So we actually utilized two materials from the SLA process here. We started off using the Formlabs draft material. This prints about 200 micron layer heights and printing exceptionally fast. What that enabled us to do is come up with evaluation, basically, to get a rough design, get the fit and finish correct. Obviously, with a part such as this, it's in the interior. You're looking at it all the time. The fit and finish has to be.
This is something. So I'm from outside of sort of automotive, coming at this, and I'm absolutely terrible at making things physically. I cannot be relied on for. I can produce something and get other people to sort of make it, but in terms of physically making it, I don't get involved in that at all, because coming from a digital background primarily, my understanding of how tolerances work is so out of whack with what the physical reality of something is, where you have temperature variation, when you've got material sort of structural sort of variations, where you've got, various forms of interference fit, and, all of these sort of very technical ways of describing how it's really hard to make shit, basically.
This is why we use the draft resin, because that enables us to evaluate all these areas on this before we commit to a final production grade material. So the material you actually see in front of you is a production grade material with the final finish,
which basically means it can go into the vehicle if you're doing especially limited.
That went into the vehicle. I believe
it could be a drivable vehicle.
Yeah, that went straight into the vehicle.
This is another one where the HMI, the physical HMI, is so notoriously expensive to prototype, which means people end up with carryover parts. They end up with, botching and trying to wedge stuff into other things. But the ability to make custom tactile components is just amazing.
And what we try and do is, what you see there is essentially a hybrid of materials that are taking advantage of their main strengths, really. So again, underneath you're looking at a rigid material. It's strong. It's designed to obviously take forces of a button push over a long period of time, and then on the top we'd actually have a tough material. So again, that would withstand the test of time of fingers keep pressing the buttons down, so you don't get that wear.
I'm just trying to give people a bit of an idea of what value is generated through this process as well, because I think people like attaching figures to. I know we don't normally do this in our presentations, but design engineering sort of aside, if you were to sort of go to a product design agency and ask them to develop something like this, you're talking hundreds of thousands. Easy. Whereas when you consider the design engineering sort of side and ultimately making it, the physical making isn't going to cost you that much, but when you combine it, you've effectively 10 times the value, really. If the value is still 100,000, or it represents a few 100,000 in savings in order to do things cheaper and more efficiently, then you can still sort of recoup some of that value, and you can still sort of see that as an investment in a project, or it's the icing on the cake, really, that you can do things to such a level and you don't leave them as stickers, effectively. Because the history of sort of automotive, I mean, I can only sort of, obviously I've not been with the company for as long as Ant has, but in terms of when you go to a motor show, now you can start to interact with things and play with them. But, there was a time when things were just like stuck on.
Absolutely. When I first started 10 years ago,
it was just everything you can't look inside it. You can't play with that. Oh, no, don't sit in there. Now
typically we'd just black the windows out, so you can't actually even see inside, because interiors.
That's the cheat code. You can just black the windows, people. That's you can have that one for free.
Simply because interiors can be inherently expensive to produce at production level, but even
hundreds of thousands just on the interiors,
production level. So
This is a really magic sort of application of it that I'm quite excited about.
Yeah, so this was something we worked with closely with Formlabs. We had a project here where we were effectively looking at custom seals in an open and closed door environment. And again, naturally, you're looking at a tooled process to be able to produce these. There's not really any other way to do it. So, as you know, Formlabs do a clear resin, a couple of different shore hardnesses, and we trialed some ideas with that. And we actually said, well, you know, that's great, but the resin's clear. You know, we need it obviously not to be clear. You can't obviously paint rubber seals or anything like that. So as soon as you close the door, it's going to wear. And this is where we started actually working with Formlabs and injecting dyes into the resin to generate the required color we need. And what we actually found was we found a really nice formulation where we were actually getting a solid black production looking door seal.
One of the things I love about Formlabs is their sort of openness to kind of listening to their customers. And
well, this was a perfect application where I asked the question and we said, do you know what, we haven't done that before, so let's give it a go. You know, it's not a closed door sort of scenario. It's, well, let's see what we can do. Let's try it. And I think we went through about 15 iterations of that part in terms of printing to get the color in and get the geometry right. But that was again fully supported by Formlabs.
And that's the magic bit, really, that it's,
and that came, you know, as you said, it came out really nice. And this was going down to, there are wall thicknesses on that seal that are going down to sort of like, you know, less than 1 mil in some areas, and we were still getting that resolution. So that was really nice.
Then in terms of SLS applications as well, it might be worth sort of describing how.
Yeah, so this is obviously the door handle mechanism that we sort of touched upon earlier. You know, this is a great example because the level of complexity in a part such as this is phenomenal, yet the part itself wouldn't appear to serve much value to an end user because they would never see it. They'd never touch it. They'd never fully understand, you know, what it actually does or what its function is within the vehicle. Yet it forms an imperative part of the door assembly. Yeah,
and without it, really, you know, again, you're looking at a carryover part, and when
Exactly.
You're creating a new sort of vehicle, you know, the cost of actually making it properly in the old ways would sometimes eclipse the cost of the car program itself.
Absolutely.
For the levels that we're talking about.
Absolutely. So, door handles are especially, you know, tricky to get right.
Who knew? Door handles, but then again, you know, it's such a robust part.
The simpler the part, the more problems it tends to cause you, to be perfectly honest.
You heard it here from Ant. The simpler part of the part,
the more trouble it causes you.
Wow. Let's go doing complex things, people. I'm sure they cause problems as well. Let's talk about these.
So this is a brake caliper. So geometry wise, this is much simpler. Nowhere near as complex. Obviously, the door handle we just saw. So why would we put that on an SLS machine?
Yeah, it's one of those things. Like, it's almost like a vanity thing that they want to customize something. We haven't spoken about the customization sort of journey much, but obviously, additive manufacturing, just like digital, provides you with the option to absolutely customize everything on a per customer level. Imagine how excited and how enriched a collector would feel if they had their brake calipers customized for them. It's just the possibility space, right? It's the fact that you could really sort of say that you are bespoke to the very last detail and actually do it. You know, not just say you can do it, but actually manage to pull it off.
And we use this on a multitude of levels as well. So obviously you've got the evaluation aspect, as you mentioned, but we sometimes use these models just purely for, you know, color and trim analysis as well. So if we want to try different calipers, you know, we won't print one and then have to paint it each color. We'll make, you know, 20 different calipers overnight and then have a different, you know, we'll have the actual part on the car. So you're not evaluating it, like you said earlier, a sticker or sort of a rough mock-up. It's a physical color correct part that we can bolt on the vehicle and actually see what it looks like.
Amazing. So really another sort of big example which represents one of our really chunky and larger sort of projects is our collaboration with Pininfarina. as part of the functional jewelry of this sort of vehicle, the Batista, we initially sort of took their concept through to a working sort of physical prototype of it, including all the interactive lighting components. And one of the things that really excites me about it is, how do you imbue something that's, that's 3D printed with a bit of electronic magic, to be able to play around with those sort of different tolerances, to be able to work out the fits, to be able to see it come to life is, one of the most magical sort of things that I've certainly experienced in automotive design, where you're taking something that, was once a visualization or an animation into, this is a real physical object that actually does something that that interacts with the CAN bus of the vehicle, takes the signals. And one of our other sort of partners, Arduino as well, that we're going to be doing some promotional activity with soon, has had this this sort of kind of enabling factor for us as well, where we can prototype things as fluently as we do with additive manufacturing on the electronic side as well. And then we get PCBs made, so custom PCBs to fit inside those parts. And I would really say that a lot of these sort of door openers, such as additive manufacturing, they open up doors to other avenues as well, and they also open up specialisms too. So, we have found ourselves at the forefront of pushing in all these different sort of direction and all these different sort of tentacles as a result of people seeing what we make as being very, very kind of high fidelity. Therefore, their expectation rises with it as well. They say, can you do this lighting program for us as well? And then you end up printing some lenses.
Yeah, I mean, this was a great example of lightings. When you're designing something on screen, and you as you say, you want to have an animation, you want to have a lighting, you can put down what you want it to do, but knowing what it's actually going to look like in physical form is actually quite difficult to simulate on a screen. So what we actually did with this project here is we 3D printed all the lenses on here, and we were trying different opaque levels on the screen, on the lenses, sorry.
So when it's shine, but you can actually, so this part actually resides on the back of the vehicle.
Yep.
So it's on the back glass. You've got a little sort of
yeah, it's just below the rear engine cover, which is their battery charging status, I believe. And
it showcases how it's almost like Iron Man's heart, really. It kind of lives and breathes. And I think this is again one of those key examples where something turned from a sketch into physical reality in the shortest possible time. And now look at us, we have a clean room, and we're actually physically manufacturing this for the production car. So please, we've been really useless at sort of growing our socials because we're too busy doing the actual job of it, what it is that we do. But if you're interested in a sneak peek behind the scenes, or if you want to ask us any questions directly, feel free to follow us on these very disparate areas. So if you go to vitalauto.com, you'll be able to access everything. But if you go to Twitter or Instagram, you'll be able to message us directly as well.
Is it worth mentioning as well our website?
Yeah, our website is getting refreshed as well, so there'll be loads of examples of our new work on there. But at the moment, it's just a placeholder for it. It doesn't have a cool construction GIF though. I want one of those again. Under construction with a little man and a shovel.
Or man on a printer, actually.
Man on a printer. That's what we're going to print our new website. That's what we should have done. We should have printed all the buttons and just taken photographs. That would have been cool. Anyway, sorry, I digress.
Actually, I think this is me who will take over. So yes, please do follow Vital Autos on social media. And also, if we don't get to all the Q&A questions, that's another way to get in contact with them to get some of your questions answered. Hopefully, we'll have some time to be able to get to all of them, but just in case. So another thing is, thank you so much for attending. We're about to go to the Q&A, but first you will receive a 3D printed sample part, actually. You can wait for an email that'll be coming, and you can request to have the part sent to you. So keep an eye out for that, and that way you can be able to evaluate the quality yourselves. So moving on, I think it's time for the Q&A. So thank you so much, everyone, for the questions you've already asked. Please keep asking questions if you have any. We'll be answering them directly with both Anthony and Shay. And if we need it, we do actually have some more technical questions that we have someone on standby just in case. But I will just start with some of the questions that have already been upvoted. Don't forget, not only can you ask questions, you can upvote some of the ones that you know you want to have answered. So I'll start with a long one from Fernando, who says, you said that you print the parts in PLA because it is recyclable, and you test it with PLA and then you print it with the target material. So how do you know that the test will also be valid for the new material?
So when I speak of testing, we're looking at evaluation in terms of design. So when we use PLA, we're not looking at the material specification as such. We're looking at the form the part creates, how it feels as a touch point, how it operates as an internal door handle. We would then look at a separate testing regime for final material specification.
Sorry, I don't know if it's everyone else, but for me, I think.
Oh. Hello, are we still there?
Hi, sorry, it seems my internet connection. I thought it was you, but it seems like it was me. Hopefully everyone can see me again.
No worries. If that answer is satisfactory, then we can move on to the next one.
Yeah. I didn't hear most of it, but I'm sure it was. Well, I'll move on to the next question.
It wasn't deflecting the answer. I think.
No, I'm happy to answer it again if needs be.
I think it was my internet, though. Of course, feel free if anyone else didn't see it to ask. But it says that my internet connection for some reason went unstable. So hopefully that stops happening. So the next question is, what would be the possible high surface roughness finish that one can obtain from SLA printing?
Right.
What was that? Sorry.
What's the high? Could you repeat that bit again? What's the high?
Yes. So the high surface roughness / finish that one can obtain from SLA printing.
I mean, typically with the materials we've used and we've experienced here, we get. I couldn't give you physical numbers, but we get an incredibly smooth, almost gloss finish on. Certainly, like they're rigid and they're white material. Most SLA resins do give you an incredibly smooth finish. Certainly so smooth that we tend to find paint don't always stick to them. We have to actually rough the surfaces up first.
Yeah, that's something that, again, because I was from outside of this sort of sphere, and I needed to understand it and get up to speed, is that there's actually a lot of no matter how well finished the thing is, there's some kind of process that you have to apply to it in order to make it ready for interaction or activation of some kind. And that could be, as Ant mentioned, you'd have to sand it a little bit, you'd have to sandblast it.
So we would typically, if we're going to obviously paint our SLA parts, we would typically shot blast them with a sort of 120 micron aluminum oxide, something like that.
Okay, great, thank you. And I did hear that answer, so we're good. Well, then I'll just move to the next question, which is again from Fernando. Does the coloring of the resin affect the final properties of the part?
Not that we've seen, and it's not something that Formlabs has seen. It's basically a dye within the resin. There obviously are limits. The more dye you add to the resin, obviously you're diluting the original the base resin. So what we had to do when we were testing was try and go beyond its limits and then start to bring it back. As I say, the more you dilute the resin, what you then start affecting is its ability to print. So you start seeing that as a physical defect within the print. Typically, if you have a good quality print, then it hasn't affected the material properties. Certainly not in the test we've seen anyway.
Well, that certainly makes sense. And I have another long question, so let me know if you'd like me to repeat it. How have you seen the technology change over time since you've been working within the automotive sector? What do you think is in store for the next decade, and how do you see it shifting?
Great question. Let's break it up a little bit. How has the technology shifted?
So for me, when I first started in niche vehicle 12, going on 13 years ago now, a lot of what I'm producing now, I would never have been able to produce back then. Sheer budgets and timeframes would not have let it. And what we tend to find is now, as a design engineer also, you start to design around those technologies, which is something, again, we never used to do. You would simply design a part for how you'd want it to be, whereas now you start thinking, actually, if I do it this way, or if I do it that way.
It's opened up the possibility for experimentation, where you didn't have that luxury of experimentation because of the timeframes or the costs.
No.
So that's number one. Number two, some things change and some things rarely change, and some things dramatically change. I wouldn't say there's been the most dramatic of changes in there, other than some of the capabilities have increased before you even get to additive manufacturing. And it's not a result of experience alone. It's the fact that the software that we use is far more sort of capable, and the sort of hardware to process it as well is far more capable too. So whereas you may have had to print something, you might get away with visualizing it first, and that visualization is going to be amazing. But it didn't take you long to do that amazing render, if that makes sense. And so that sort of computational increase has resulted in the desire is still the same. They still want to print this sort of part, but now they're like, okay, but could we show a version of it lightweighted as well? Could we test the sort of tensile qualities of it if we added this bit to it? Or in terms of sort of overall aerodynamics, those processes that were just so costly to do are now, they've become a service. You could send something away, it gets printed there, super sustainably, and then they test it in a wind tunnel, for example, or they'll use a CFD process on it, and it's almost the time compression is insane.
I think the other interesting thing is, when I first started, the sort of the go-to technology was obviously subtractive manufacturing, CNC machining. That was always driven by complexity, really. That was the main driver in terms of either A, what it would cost, or B, how long it would take. Whereas now, in the world of additive manufacturing, it's actually not driven by complexity. It's driven by volume and general size, and which I think is only getting better and better and more accessible as time progresses.
Right.
And I think looking ahead, the capability of our printers now are exceptional, but I think they're only going to start getting bigger and bigger, and then more accessible as well.
Yeah, and maybe some of that accessibility is becoming more accessible to people from other disciplines as well. So you don't need to have access to the most sometimes especially when we're doing creative forms, we don't necessarily go into CATIA or SolidWorks or anything like that. You could actually create, Ant's going to hate me for saying this, but you could actually create something in Blender just as well. Yeah, he's laughing now. So yeah, but no, it's a serious sort of consideration. There's various sort of costs prior to getting somewhere as well. And I think someone's mentioned that they're from a school, so not an industry. Totally get that. Some of even without the 3D printing technologies, a lot of the people that we have on the sort of factory floor, so to speak, have a tremendous background in physical crafting of things as well. They paint miniatures in their own time. They know how to do intricate things. So I think there's a complementary sort of skill set that helps when you've crafted things physically and you've done things the old way. You can actually combine that with the new and then exponentially improve your output, as opposed to when you're just so fluent in one thing and you can't really sort of shift into the other area as well. Be more sort of David Hockney in the approach. And
we rarely look at 3D printing replacing technologies. We use it to enhance the technologies we already have.
Yeah, augmentation, not amputation, really.
Absolutely.
But then it sometimes leads to amputation because you won't go back. Right, sorry, it just went a bit to media theory. But
It's fine. I live in France. It's amputation. I know it well. But sorry, history joke. So next question is, how do you manage your AM projects and prototypes that move towards the next stage? For example, how do you decide on the right technology, additive versus subtractive manufacturing, or SLA versus SLS?
what a great question.
Yeah, I mean, that is a big question. Typically with most projects, there's never really a perfect process or technology. Sometimes we'll use all our printing technologies and see what gives the best outcome. It can depend on
you've got all rounders, but you haven't got a one size fits all when it comes to stuff like this.
It can be dependent on cost. It can be dependent on time frames. It can be dependent upon the complexity of the part. As I say, typically for us, we would use our FDMs for sort of large objects, and we'd use our PLA for our base structures, and for which we'd put then smaller printed parts on top of it. We'd use our SLAs for, as I say, finished parts, interior parts, as we've already mentioned, and our SLS parts. We love using our SLS machines for all the sort of functional stuff that goes on behind the scenes, everything that's behind the panels you never see, that are doing a job, that are operating a mechanism.
Everything bit.
Yeah.
So yeah, in short, there's no one size that fits all. How do we choose? It's variable depending on the sort of qualities required for the end use. That's, you always start with the end use and then you work backwards from that. What do they need to do with it? How does it need to be interacted with? Those are the questions you answer. Because the cost is actually pretty low, it's very rarely based on cost. That's not a huge determinant.
It's not the main driver.
Unless you're doing something really crazy, like making a sculpture that's very sort of intricate, and you don't have any idea about the sort of the cost involved with making it that intricate. That is definitely a disparity. So if you're from the contemporary art field and you sort of want to make a sculpture and you don't have a clue about how it's sort of made, we'll give you that consultancy so that you can understand what the limitations are, and then there's a choice really from an artistic perspective whether or not you want to sort of go ahead with it.
Absolutely.
Or you can shake a fist at the sky.
Often the preferred method for many people, but I'm glad to see we're evolving. Well, we're nearly done actually, so I just see one more question, which is, what obstacle do you still face in order to use AM technology for end use? I'm assuming end use parts.
I've got some obstacles for end use parts, but go on. Do you
I mean, in terms of obstacles, I've already touched upon it. One of the main drivers is size.
Right.
You typically find that the larger the printers, the cost goes up exponentially, really. So that's always something we're always working with here. Bigger is better is always that motto. In terms of end user components, we're already producing end user components with our printers. I think it's just more. So
in automotive, just to be really clear, for a car to be vehicle to be roadworthy, and it needs to be extensively homologated. Really fancy word to make sure that it's tested and safe, and it passes all these different sort of regulations. Just like you have like a CE mark or an FCC mark for a piece of electronic, electronic device. You need to sort of go through that for vehicular sort of prototypes as well. So that I can't really sort of comment on. We have specialists who help us with that work. They pore over the regulations and they give you a verdict as to whether something does conform or it doesn't conform. It's quite a straight sort of process. Then it gets insured for use. So that's that. But in terms of what actual sort of limitations there are, I'm going to give a very broad sweeping sort of statement here that the tools that we're using today in terms of, and this refers back to a question that we had earlier as well, the tools we use today are so primitive to what we'll have in the near future. Somebody said this to me sort of 15 years ago at a conference that I went to, and I thought, you're absolutely right, but has that sort of advance happened as quickly as we want to? I think we're probably going to see a far more exponential sort of speed in how those things are going to advance, to the point where, you know, really our sort of input is going to be purely sort of subjective or artistic or incredibly granular in a way that the tool hasn't really been configured for that use. But ultimately what I'm trying to say is that the tools are so primitive that you still hit optimization issues in the program itself, not in what you're attempting to do. I want the tool to allow you to do stupid things. I want the tool to be able to say, I have a ridiculously high polygon sort of scan and I know what to do with it. But the tools don't do that. The tools expect you to optimize it using a hammer and chisel and whatever you can digitally and loads of duct tape to get the same result. And that's not often, you know, that's the barrier in expression, really, to allow you to fully sort of express this component or whatever. You really need better tools, and the tools just aren't there yet, in my opinion, or they're so prohibitively expensive. You know, to use Pro Tools to do stuff, you're spending more than you are on the printers. And
even then, it's not always giving you what you want.
Yeah, and even then, yeah,
you know,
so yeah,
it's making a lot of assumptions.
To blinking and waiting for that to happen.
Yeah, which I mean makes sense though, seeing how fast it's gone the past few years. Maybe, as you said, we can hope to have some more exponential growth coming soon.
So,
well, in any case, I think we're just about done anyway, and that was my last question. So I will just say once again, thank you everyone for attending, and thank you especially to Anthony and Shay for being here. It was a wonderful presentation. Thank you for making the time. And just a reminder, if you would like to rewatch it again, it will be available later on YouTube through 30 Natives as well as through Formlabs. So stay tuned for that. And have a great afternoon, morning, day, whatever. We have very many different time zones, so it's always hard to say, but have a good one, and see you for the next webinar. Bye.
Thank you very much. Bye. Bye.